Hello guys and welcome back to another video. In this video we'll be talking about step 4 of the KDD process, which is data pre-processing. Before I start off with today's video, I want to give a huge thank you to every single one of you who have interacted with my previous videos, and especially for those people who have interacted with my post on LinkedIn. As of today, the LinkedIn has just over 9,000 views on my post, and this is the highest I've ever had since I've posted any sort of content on LinkedIn. So thank you so much for every single one of you who have viewed my LinkedIn post. In case if you guys want to get in touch with me on LinkedIn, I have left the link in the description box below. Hit me up and let's connect. But for today, let's get started. We're going to be talking about data pre-processing. This is a very interesting subtopic of the KDD process. In data pre-processing, we'll be talking about two main aspects. We'll be talking about feature construction, and we'll be talking about feature selection. Now let's put everything into perspective. Let us understand what is feature construction and feature selection. Feature construction means constructing a new feature. Feature is also known as variables in your dataset. Now, when we're talking about feature construction, we basically want to focus on two things which can help construct a new variable or a new feature. The first is domain knowledge, and the second way is through aggregations. Now, why is it important to construct a feature in our dataset? Now, let's say we have a dataset. Now, this dataset, let's say, has three variables: variable 1, variable 2, variable 3, and 4 rows. Now, a lot of time what happens is when we are getting this data from third parties, from APIs, or through web scraping, a lot of times these data does not hold variables which can have predicting powers. And that is the reason why feature construction plays such an important role. Now, let's say if you're working with an insurance dataset, and let's say you have some sort of a domain knowledge within insurance industry. Now, if you're given different sort of variables, let's say you're given variable 1, variable 2, and variable 3. Now, let's say variable 1 and variable 2, as a domain expert, you know that it does not hold any sort of predicting powers. What you can do is basically create a new field and create a new variable. Now, this variable could have a higher predicting power compared to variable 1 and variable 2. Now, feature construction is all about adding new variables that could have predicting powers for our modeling. The way you build these new variables are through domain knowledge and through aggregations. Now, this was just an example of how through domain knowledge you can add a new field. Let's say within insurance industry, let's say this field could have data for all those people using black box in their cars. So that could be one of the variables that you could use for your feature construction. Another type of feature construction is aggregations. Now, aggregations is to do with adding obviously new field because it's a subcategory of feature construction. Now, with an example, let's say you're working with the sales data. You have, let's say, date, you have sales, and let's say this is month 1, month 2, month 3. Let's say you have 3 months of sales data. Now, one type of feature construction that you could perform here is create a new variable, and this variable could hold the data for all these 3 months. So basically you can call this variable as 3 months average sales, and this feature could collect all the data for the last 3 months and it can perform an average. So this is one way of constructing feature, and this is through aggregation method. So that was feature construction. Now coming to feature selection. Now what is feature selection? Feature selection is selecting variables from a given data set. Now let's say if you have a data set, and let's say you have 100 variables in this particular data set. Now feature selection would mean that you can create, let's say, subset 1 where you can have, let's say, 20 variables. Then you can probably create, let's say, a subset 2 where you can have 10 variables. Now feature selection is all about picking out variables from the entire data set. Now, we provide feature selection because we cannot model our data with 100 variables in it, because let's say from those 100 variables, 50 or 60 variables may not hold predicting powers. So feature selection helps us select those variables which could have high predicting powers and which could be used for our modeling. Now, there are different ways of feature selection. The first way, the first way is the filter method. The second way is the wrapper method, and the third way is the embedded method. Now your filter method works best with your univariate dataset. The wrapper method works best with multivariate dataset, multivariate data, not dataset, sorry, data. And your embedded method is basically an extension of your wrapper method. Okay, now what's the main difference between using a filter technique and a wrapper technique? Now a filter technique is to do with the relevance of a feature, whereas the wrapper technique is to do with the usefulness of the feature. So this is the main difference between a filter technique and a wrapper technique. Now, what are the different methods of actually doing filter based feature construction? So filter based feature construction. So what are the different methods? So the first method you can use to perform a feature of, sorry, not a feature construction, sorry guys, it's feature selection. Feature selection. So the first way is you can do some sort of an information gain, where you can look at the different variables in your data set and actually see which variable has a higher information gain score, and that way you can select features for your dataset or for your subset. Another way of doing a filter based feature selection is through passes correlation. What you can do is basically construct a correlation matrix where you can find out variables which are highly correlated to each other and also variables which are not highly correlated to each other. When you're working on correlation, you need to understand that there may be a problem of multicollinearity. Now, with multicollinearity, what happens is that when you have variables which are highly correlated, then you can leave out one variable from the two variables. So let's say if you have variable 1 and variable 2, and these two variables, let's say, are highly correlated, then you can leave one variable out and use another variable. So when you're doing process correlation, you need to look out for multicollinearity as well, and you need to remove any sort of multicollinearity that may exist in your data set, because then that could have a ripple effect on your modeling as well. So you need to look out for multicollinearity when you're doing Parsons correlation. Remove any variables which have um, high correlation. You can also run a VIF test, which is a variance inflation factor, um, which could point out variables which are highly correlated, and that way you can leave out highly correlated variables from the subset. So you can run a VIF test. You can look out for multicollinearity in your Parsons correlation as well. Now, when you're working with the wrapper method, there are different techniques that you can use. The first one, you can use a recursive feature elimination technique. You can use a PCA, which is principal component analysis. Um, you can also use any genetic algorithms. You can use Baruta, which is part of the random forest algorithm. Mallow's CP. So what this would effectively do is would try to find the optimal number of variables you should have for modeling. So it would give you a number, let's say 6 or let's say 10, based on the variables you have. Let's say if you have 40 variables, it may give you 6 variables, and it may say that, okay, based on Mellow's CP, you should have 6 variables for your modeling. This would give you the best results. So you can use Mellow's CP to find out the optimal number of variables that you can use for modeling. So that's another way of doing feature selection for your models. Um, the last one is basically your embedded method, and within the embedded method you can use your L1 lasso regularization, or you can use your decision trees. So these are a few things that you can use when you're doing a feature selection. Now let's just summarize what we have learned today. So when we are dealing with data pre processing, let me change the color. Okay, so when we're dealing with data pre-processing, there are two main steps. The first one is your feature construction. The other one is your feature selection. For feature construction, you can do it through domain knowledge or through aggregations. If you're working on feature selection, you need to understand there are three ways to do feature selection. You can use the filtering technique. Now within filtering technique, you can either do information gain. You can run a Parsons correlation. Second method was your wrapper method. Now in the wrapper method, you can use your recursive feature elimination, or you can use um, genetic algorithms. You can also use Baruta. Sorry. Also use Baruta, or you can also use Mallows CP. And lastly, you can also do embedded techniques for feature construction. For feature selection, you can use L1 lasso regularization, or you can use decision trees. So guys, here's a brief summary of the different techniques that we have that we can use for our data pre-processing. I have been getting a lot of messages on my LinkedIn asking me to do a practical example of all these steps that I'm talking about on Python or R or SPSS. So I'm going to do that soon. So this was data pre-processing. I hope this video helped every single one of you who wanted to get some understanding of how data pre-processing is done, what are the different ways of doing data pre-processing. Once again, thank you so much for sticking to the end of this video. And as I said, in my previous video, I'll be creating a Dropbox link to share all these notes with you, so that you guys can refer to it whenever you guys like it. So thank you so much, guys, for sticking till the end. And do leave a like, do subscribe to the channel. It really helps me a lot. And I will see you guys on Friday, where I will be talking about data modeling and the different algorithms we can use to model our data. So I'll see you guys on Friday. I hope you guys have a great week and take care. Bye bye.